You know what's really been bugging me lately?
What's that?
Like, there's this huge desert here in America,
Mm-hmm.
and there's all these tornadoes. Like, I swear to God, there's one like every other week.
Yeah.
Why do you think all that's why do you think all that's happening?
I don't know. Let's try and find out.
I overheard your conversation and know exactly what you're talking about. I can totally explain this to you. Please join me in my classroom so I can explain it.
All right.
Sounds good.
Okay, so the first step in this process is wind flows from the west towards the Rocky Mountains.
Wind blows air from the west towards the western side of the Rocky Mountains. Once the air encounters the mountains, it is forced to ascend the mountains, cooling as it rises.
Oh my gosh!
Whoa!
You're blowing my mind right now!
Does it get any better?
It sure does. Wait until you hear this next part.
Oh, I'm so excited!
As the air cools, it eventually reaches saturation, which is the point at which the maximum amount of water vapor is allowed in the air. Once this occurs, water begins to condense out of the gaseous state to liquid and ice, forming clouds. As water continues to condense, the clouds eventually precipitate.
Okay, for this next part, we're going to head to the lab.
After most of the moisture is removed from the air from condensation and precipitation, the air makes it over the tops of the mountains and then descends. As the air descends, it then warms due to adiabatic compression. What this means is that as the air descends the mountain, it experiences increasing pressure from the overall atmosphere. This increasing pressure does work on the air, increasing its internal energy. This warms the air and makes it much hotter. The air is therefore much drier and hotter. This is why we have the Great American Desert on the eastern side of the mountain. In summary, air moves eastward towards the mountains. Once it encounters the mountains, it is forced to ascend, where it then cools and forms clouds and precipitation. Once the air moves over the mountain tops, it descends, experiencing adiabatic compression, which warms the air. This hot, dry air results in the Great American Desert.
Okay, so now since we know why the western plains are so hot and dry, let's look at an actual visual representation of an actual phenomenon generated by this. So this image obtained from tornadochasers.net helps display this phenomenon. According to Meteorology Today, a dry line is a sharp gradient in moisture, in this case between hot, dry desert air to the west and warm, moist Gulf moisture to the east. This boundary helps serve as a forcing mechanism that is needed to drive the strong convection needed for strong storms, which help produce the strong tornadoes in the American Great Plains. Well, guys, I hope that answers your question of why there's a desert and so many tornadoes in the western United States.
Yeah, it really
Thanks a lot.
You're the best, Professor Smith. I'm gonna be just like him when I grow up.
That was so much fun.
Wait until you hear this next part.